This is Trig 4.3, part 2 of the lecture slides. So we just started to outline some of these Pythagorean identities. And the sine squared plus cosine squared theta equals 1, this is an important one. And it will come up probably the most frequently out there. But what does it mean? What this means is you take the sine of a value and you square it. Now I know, why do they put the little square there? Well, they want to make sure that you don't think that it's this. These two things do not equal one another. In this case, order of operation tells me I square the angle and then I take the sine. Well, that's not what we want. We want to take the sine of the angle and then square that. So this value here, mathematicians like to write it this way. Why? I have no idea. Probably they don't want to have to work with parentheses. They want to shorthand it as much as possible. So that is what this means. These two things are equivalent to each other. And if I have sine squared theta plus cosine squared theta equals 1, this is the one we're going to start with. Well, let's do a little bit of work with that. If I have sine squared theta plus cosine squared theta equals 1, and I want to divide everything by cosine squared, right? As long as I divide everything, I haven't broken the rules of algebra. So I've got to divide here, and divide here. So my first value, I wind up with sine squared over cosine squared. My next value, I wind up with cosine squared over cosine squared. And then I end up with 1 over cosine squared theta. Well, using these reciprocal identities and quotient identities here, what is sine divided by cosine? It's tangent. So this right here is really tangent squared theta. A fraction, where it has the same numerator and denominator, that's just 1. And 1 over cosine, that's just secant. So if you'll notice, the second identity we just derived from the first identity. And all we did is we divided everything by cosine squared. Not that I'm expecting you to memorize that, but really that's why this first identity is the one that's most important, because you can derive everything else. And, spoiler alert, how do we get to this one? We divide by sine squared theta. Right? In this first example, we divided by cosine squared theta. Well, this one, if we divided everything by sine squared theta, we would get this identity. But like I said, I will give you this formula sheet on the test. Let's look at some examples of how we can kind of apply these identities and work with these identities. And this is something that you will either like or you will not. It's really something that some students like and some students do not. So let theta be an acute angle such that the sine of theta is 0.6. Find the value of cosine theta and tan theta using identities. Notice I'm not going to draw a triangle. I could, right? I definitely could. I could say, well, sine is just a 6 over 10. Let me make a triangle. Feel free to do that, but let's try to also do it a different way. We're going to kind of stretch ourselves and try to use these trigonometric identities. Well, for letter A, I want to use a trig identity that uses both sine and cosine and nothing else. And so the identity I want to use is that one I had in our red star of sine squared theta plus cosine squared theta equals 1. Wherever I see a sine of theta, I'm going to plug in a 0.6. Okay. Then I go ahead and calculate 0.6. The quantity squared is 0.36. Notice I'm just using my algebraic skills here to solve. I subtract 0.36 on both sides, so I get cosine squared theta equals 0.64. Now I take the square root of both sides, just like I would if I had x squared, and I get that the cosine of theta is equal to 0.8. There we go. Now let's look at letter B. Oh, apparently I need to fit it on this page. Let's insert a new page. Now I want to find the tangent of theta. Okay, I now have sine and I now have cosine. So let's use that quotient identity. That tangent is sine divided by cosine, which would then be 0.6 divided by 0.8, and I get out 0.75. Yes, if you want to convert all of these to fractions, that is totally acceptable. I was just using kind of the examples the way that had been laid out in the book. And I think the book kind of wrote these as decimals to try to steer you towards not using a triangle, although you definitely can use a triangle. Let's look at our next example. We have another angle, acute angle here, such that the tangent of theta is 1/3. Find the values of cotangent and secant. Well, the tangent and cotangent one, right, those are reciprocal identities there. Cotangent is just going to be 1 divided by tangent, or the reciprocal. 1 divided by 1/3, I get out 3. That one wasn't too much work. For letter B, I want to find the secant of theta. So for that one, I'm going to use this identity. Right? I know what my tangent value is. It's 1/3, and I need to square that. And I want to find the secant. So I go ahead and 1/3, the quantity squared is 1/9. I then add that to 1, and I get 10/9 is equal to secant squared theta. I then take the square root of that. So I get that secant theta is the square root of 10/9, which if I break that out, square root of 10 over square root of 9, I get the square root of 10 over 3. Final answer. Now let's look at how we can kind of prove some things. I'm giving you the answer, right? The answer over here on the left should equal the answer on the right there. So I have to somehow show that sine times cosecant is equal to 1. Well, we've got the sine of theta. Now let's rewrite cosecant in terms of sine. Right? So I wind up with the sine of theta over the sine of theta, which equals 1, right? I have just proven that the left-hand side is equal to 1. And I know you might think of the geometry proofs from when you took geometry class with the 2 columns and how formal it is. That is not what I'm looking for. I'm looking for an algebraic presentation to prove that the left side equals the right side. All right. Let's talk about this next example. I have 2 binomials that I am multiplying, right? Looks a little similar to something like this, which what I have to do is FOIL. So let's go ahead and FOIL all of this out. I get cosecant squared theta minus cosecant theta cotangent theta plus cosecant theta cotan theta. So those are going to cancel out. Let me show all my steps here. And then minus cotangent squared theta. And we need to show that that equals 1. Well, these 2 cancel out. So I get cosecant squared theta minus cotangent squared theta. And does that equal 1? Well, let's look at our identities that we have. Let's look at how we can use some of the identities that we have to really get this information. One of the identities that we have is that 1 plus cotangent squared theta equals cosecant squared theta. So why don't we take this here and substitute it in where I see a cosecant squared. So this is now 1 plus cotangent squared theta minus another cotangent squared theta, and we want to see if that equals 1. Well, these 2 cotangent squared thetas are going to cancel each other out. So we wind up with 1 equals 1. And we have there shown that these this whole thing that we started with, which is pretty ugly, right, is equal to 1. So that's kind of a little introduction to trigonometric identities. When we get to further units, we will be doing more of this. So just know you may not always see the path right away. You may not always see the answer right away. You may go down the wrong path, realize you've chosen the wrong identity to work with, and then have to start all over. Do not worry, it just comes with time. It just comes with practice. The last thing we want to do is talk about some application problems. And we did these quite a bit in Algebra 2. I have a kind of practice worksheet with a whole bunch of different word problems on it if I feel like we need to do more practice with it. But I'm hoping, because our book uses the exact same vocabulary, this whole angle of elevation, angle of depression, that we should be able to kind of work with these different word problems and be successful. So let's talk about it. Using trigonometry to solve a right triangle. A surveyor is standing 115 feet from the base of the Washington Monument, as shown in the picture. The surveyor measures the angle of elevation to the top of the monument as 78.3 degrees. How tall is the Washington Monument? So thankfully, they've given us a nice little picture here, right? This is my angle of importance. So this is my opposite side and my adjacent side. I don't care that much about the hypotenuse because I'm trying to find the opposite side. So I need to think of what trig function uses opposite and adjacent. Well, TOA, right? Tangent. We could use cotangent, but tangent's so much easier. It's on our graphing calculator. So the tangent of 78.3 degrees is equal to opposite over my adjacent side, which is 115. I then multiply both sides by 115. I pick up my calculator. Make sure you are in degree mode, right? This was in degrees. It has the degree symbol. We want to make sure that we're in the right mode. I do 115 times tangent of 78.3 degrees, and you should get out about 555 feet. So like I said, if I feel like we need a lot more practice with some of these word problems, I can do that, but we'll see how the homework assignment goes. So by now you should be recognizing, right, that whenever we find these angles, these major angles, our sine and our cosine values are always somewhere between -1 and +1. And so if you're trying to figure out the measure of an angle, and I said, well, we know the sine of 30 is 0.5, we know the sine of 45 is 0.7, so if I'm trying to figure out what angle has a sine of 0.6, it must reside somewhere between 30 and 45 degrees. So the way that we kind of, ask you guys as students, if I give you a word problem, try to think of what potential correct answers could be. This is kind of what I want you thinking about, right? If you try to solve for this here, I'm trying to figure out an angle that has a sine of 0.6 and you get 340 degrees, something probably went wrong. So try to use your kind of practical understanding of what should be an expected answer to help you as you're solving these word problems. Thank you.